All right. Hello, year 8, 8182. You can see me, I can't see you, but we're going to do a lesson today. We're going to start off with a quick recap. This is just to kind of make sure that we're kind of all up to date, all up to speed. There's probably three main things that you guys need to remember. The first one there is probability. So probability is, remember, it's your formula that you're always going to have every time. It's going to be number of favorable outcomes over or divided by the number of your total outcomes. All right. The other thing that we should hopefully remember as well is the sum of all outcomes. If we add them all together, they should always equal to 1. All right. And the last thing, which was from last lesson or from the last kind of online thing, talking about mutually exclusive events. To put it very simply, mutually exclusive events, they cannot happen at the same time. For example, if I rolled a dice, there's no way I can roll a 1 and a 2, right? Or if I was to toss a coin, there's no way I can get heads or tails, heads and tails at the same time. So we call those mutually exclusive because they can't happen at the same time. Right, so now we're going to move on and we're going to look at some, I guess, what we call visual representations of probability problems. Right, so when there's probability problems, sometimes there's ways that we can write things out or even draw things that kind of help us to understand. And the first one that we're going to look at today and over this lesson and the next one is Venn diagrams. Okay, now I want you guys to write this down in your books. I expect that all of this will be done, so I will be checking. We have Venn diagrams here, and all it is it's trying to say that there's the outcomes of an event. What we do is we group them kind of in circles, and then we place it inside a rectangle. Right now, it sounds really vague and simple, but I'll show you what that might look like. So for this first one here, we've got understanding a Venn diagram. We're going to figure out what it actually looks like, how it actually works. So let's say if we roll a dice, right? I think you roll a dice, you can get 1, 2, 3, 4, 5, and 6. There's two events. I can have event A, which I'm going to call rolling an even number, right? So that's one thing that I'm looking out for. The other thing I'm looking out for is event B, which is rolling a number greater than 4. So what I'm going to do here is whatever my two events are, I'm kind of going to draw circles. So I'm going to draw these beautiful circles. Look at that. Boom, boom, perfect. And what I'm going to do is I'm going to label one of them for A, for event A, and the other one I'm going to label B for B. Right. So here I'm going to look, okay, if I roll an even number, what are my even numbers? So if I think about my even numbers, let me write this on the side here. If I think about my even, I don't know why my writing's so big. That's better. Let's try that again. So if I was to write this here, even, my even numbers is going to be 2, 4, and 6. That makes sense. Now, if I was to roll a number greater than 4, that would be 5 and 6. We don't count 4 because 4 is not greater than 4. So we just have those two numbers. So here, we can kind of see that event A is supposed to be your even numbers and event B is supposed to be your numbers greater than 4. So if you kind of take a look here, we can kind of see an overlap, right? 6 appears in both of these, in both A and B. So guess where that number is going to go? I heard you, you guessed it. It's going to go right in the middle. So I'm going to write it here. Boom. So that number 6 goes in between, in the overlap between A and B. That means it's part of event A because it's an even number. And it's also part of event B because it's a number greater than 4. All right, so let's see what else we can kind of put in here. So all our even numbers, we've got 2 and 4. They don't really fit anywhere else, so I'm going to write them in this one, 2 and 4. And then for B, the numbers that are greater than 4, the only other one would be 5. Right, but we also have to kind of look out for here is there's a couple numbers that we haven't used yet. We haven't got 1, we haven't got 3, and I think that's it. We just don't have 1 and 3. So we're going to put 1 and 3 on the outside because they don't belong to either event A or event B. Hopefully that makes a little bit of sense. Okay, so that's how we kind of understand or how we use a Venn diagram. So there's parts that belong to event A and there's parts that belong to part B. And then there's stuff that belongs together. That's kind of in the middle. That's that 6 that we have there. And then there's also stuff that doesn't belong to either. So they will go outside. Now, all of these kind of have to be within our giant rectangle that we have because it's all part of rolling a dice. Cool. Now, The other thing that you might be asked to do is not only to kind of draw one, but you'll be asked to read one, or like to read some information off it. So this one, I've got an example here. It says this Venn diagram represents the number of students in a class that, and hopefully this is you guys, that write down their class notes, that's you, and also complete their homework. You guys know who you are. So let's say, for example, we've got this kind of Venn diagram. So we've got A, which is, we've got this diagram here. Now, we've got some questions that we're going to try and answer. The first one here is, how many students are actually in the whole class? Now, the way that we would figure something like this out is we'd actually add all the numbers together, right? Because there's 20 people plus 15 people plus that 1 plus that 9. If you add them all together, that should be 30, 45. If I did my math right, 30, 45. Yeah, there's 45 students in the class, right? Maybe I should use a different color so you can see what I'm doing here. Let's make it green. Okay, so there's 45 students that are in the class. Now I'm just going to turn it this way so we can hopefully kind of see this as we go. Okay, so if we continue on, is we want to find how many students, this is part B, did not write class notes and did not complete homework. So if we look here, the ones that didn't do either, well, it can't be in what circle A, because those are the ones who wrote down their notes, and B is who completed their homework. Who didn't do either would have to be the people on the outside, and we can see that there are 9 students. So that would be 9. All right, now question C, it says, how many students wrote class notes and completed the homework? So sometimes it gets a little bit kind of difficult to see. So I'm going to write here on top of A kind of represents notes and B kind of represents homework. So that's just going to help me to kind of see what I'm actually doing. So how many here wrote class notes and completed the homework? Well, it must be the overlap. It must be the people that did both. So in between A and B, our answer should be 15. All right, now who wrote class notes? Now this is an interesting one. If we think here, how many people actually wrote notes? So we can see that there's 20 that just wrote notes, but then we've also got those 15 people that did both. So what we would do here is we'd actually add them both together. So how many people wrote class notes? It's those 20 people that just wrote the notes, and it's also the 15 people that also wrote the notes. So that would be a total of 35. How many people completed the homework? Well, again, we can kind of see, well, there's 15 that did both, and then there's an extra 1 guy who did, or girl. So that would be 16. Okay, and the last one is how many people only completed class notes? So here we would look at everything that's in A, but they only completed the class notes, they didn't do their homework. Well, that would have to be, there's 20. And how many people only completed their homework and didn't do their class notes? That would be 1 person. Okay, so hopefully that gives you a little bit of an idea of how Venn diagrams kind of work. We'll be going a little bit more in depth in the next lesson in how to kind of put one together in a bit more detail. But I hope that helps, and I'll see you guys later. Bye.